This is the solution to example 6 from notes 1.6. And we're going to solve an equation that has two radicals in it. So normally when we solve an equation with a radical, we want to isolate that radical. So what I'm going to do is I'm going to move the second radical over to the right side of the equation by adding rad 2x plus 3 to both sides of the equation. This isn't necessary. We could square both sides from the start, but it makes it a little bit easier to work with it in this form. So now we have 2 times the square root of x plus 1 is equal to 1 plus the square root of 2x plus 3. In order to undo the square root on the left side of the equation, I'm going to square both sides. I'm not going to divide by 2. That would leave me with some fractions on the right side that I don't want to deal with. So when I square both sides, the left side is going to become 4 times x plus 1. The right side, remember that what we really need to do is to FOIL this out. So I can think of this as 1 plus the square root of 2 plus 3 times 1 plus the square root of the quantity 2x plus 3. When we distribute this, the left side becomes 4x plus 4, and the right side, I multiply the first terms, I get 1 times 1 is 1. The outer terms, 1 times rad 2x plus 3 is rad 2x plus 3. The inner terms are rad 2x plus 3 times 1. So once again, I get rad 2x plus 3. And when I multiply the last terms, I get rad 2x plus 3 times rad 2x plus 3, which gives me 2x plus 3. What I'm going to do now is combine like terms. So on the right side, I can add the 1 and the 3 together to give me 4. So the left side, I have 4x plus 4. On the right side, the 1 plus 3 gives me 4. And then I have square root of 2x plus 3 plus the square root of 2x plus 3. That gives me 2 times the square root of 2x plus 3. And then I still have plus 2x. At this point, I can subtract 4 from both sides of the equation, so those 4's are gone. And I can also subtract 2x from both sides of the equation. That will leave us with 2x on the left side is equal to 2 times the square root of 2x plus 3. Here, we can divide both sides of the equation by 2, so we get x equals the square root of 2x plus 3. To undo that square root on the right side, we can square both sides. So that will leave us with x squared is equal to 2x plus 3. This is a quadratic equation. We solve it by putting all of the variables, all the terms actually on one side of the equation. So I'm going to subtract 2x and 3 from both sides, and I'm going to set the other side equal to 0. So I have x squared minus 2x minus 3 equals 0. This factors nicely. I want two numbers that multiply to negative 3 but add to negative 1. So those are negative 3 and positive 1. So I get x minus the quantity x minus 3 times quantity x plus 1 equals 0. Using the zero product property, we can find that x equals 3 or x equals negative 1. However, since we squared both sides actually twice in this case, in order to find these solutions, we need to check for extraneous solutions. So I'm going to check both of these. So I'm going to, first I'll check x equals 3. So when x equals 3, I'm going to substitute that back into the original equation. So I am going to have 2 times the square root of 3 plus 1 minus the square root of 2 times 3 plus 3. I want to know if that's equal to 1. So I have 2 times the square root of 4 minus the square root of 9. Is that equal to 1? So 2 times 2 minus 3. So I have 4 minus 3, and 1 equals 1. Check. So x equals 3 is a valid solution. And now we're going to check the second solution, see if it's extraneous or not. So I'm going to check x equals negative 1. I'm going to substitute it back into the original equation. So 2 times the square root of the quantity negative 1 plus 1 minus the square root of 2 times negative 1 plus 3. Is that equal to 1? This becomes 2 times the square root of 0, which is 0, minus the square root of negative 2 plus 3, which is 1. So we have the opposite of the square root of 1, which is negative 1. Is that equal to 1? No. So x equals negative 1 is extraneous. So we're going to cross out that solution. And so our only valid solution is x equals 3.